William E. Boeing was born in Detroit, Michigan in 1881, the son of Wilhelm Boeing, a German immigrant who had accumulated substantial wealth through timber and iron ore holdings in the upper Midwest. He attended Yale University's Sheffield Scientific School, but departed before completing his degree, drawn by commercial instincts that formal academic life could not fully accommodate. He relocated to the Pacific Northwest in the early 1900s, where he accumulated independent wealth through lumber operations along the coast of Washington state, an industry that gave him both capital and a practical understanding of large-scale materials processing and logistics. His introduction to aviation came at the Alaska Yukon Pacific Exposition in Seattle in 1909, where he observed demonstration flights and recognized a technology whose potential he believed was being systematically underestimated by the established industrial order. By 1915, he had purchased his first aircraft and enrolled in flying lessons under the instruction of Glenn Martin in Los Angeles, an experience that converted intellectual fascination into hands-on conviction that he could build better aircraft than those then available. He returned to Seattle and, in partnership with Conrad Westervelt, a U.S. Navy engineer stationed at Puget Sound, designed and constructed the B-29 seaplane, a twin-float biplane that completed its first flight over Lake Union in June 1916.
On July 15, 1916, Boeing incorporated the Pacific Aero Products Company in the state of Washington, the legal entity that would eventually become one of the most consequential industrial organizations in American history. The U.S. Navy reviewed the B&W and declined to purchase it, but the exchange established a working relationship with military procurement channels that would prove enormously valuable across the following century. Boeing's founding instinct that aviation's commercial and military applications were inseparable and that the federal government would remain the most reliable customer for aircraft technology proved prescient in ways that extended far beyond anything the company's founders could have anticipated in that first summer of operation on the shores of Lake Union.
When the United States entered World War I on April 6, 1917, Boeing moved quickly to convert his company's limited resources into a vehicle for wartime production. He renamed the enterprise the Boeing Airplane Company on April 26, 1917, a rebranding that signaled a new institutional orientation toward military clients and away from the more speculative commercial possibilities that had shaped the company's initial conception. The Navy awarded Boeing a contract for the Model C, a two-seat trainer seaplane intended to prepare pilots for combat duty, and production began at the converted Heath Shipyard on the Duwamish River south of Seattle, a facility whose original purpose in boat manufacturing translated reasonably well to the wood and fabric construction methods of early aircraft. The Model C was not a transformative design, but it was functional, deliverable, and produced on a timeline that impressed Navy procurement officials accustomed to the chaotic timelines of early aviation manufacturing. Boeing trained production workers and built institutional knowledge about the practical requirements of aircraft manufacture during those wartime years, an accumulation of expertise that would prove more durable than any of the specific aircraft types produced. The armistice of November 1918 brought an abrupt end to military contracts, collapsing Boeing's revenue and forcing the company to confront the same peacetime adjustment that had driven most of the early aviation industry toward bankruptcy or consolidation. Boeing pivoted to furniture construction and speedboat manufacturing to keep skilled workers employed through the lean years, a pragmatic stopgap that preserved manufacturing capability rather than allowing it to disperse into other industries. William Boeing's conviction that commercial and military aviation would eventually generate substantial demand allowed the company to sustain itself through the post-war period without abandoning its core technical identity. The relationships built during those early Navy contracts, the patterns of communication with federal procurement agencies, the institutional credibility earned through reliable delivery, would compound in value over the subsequent decades in ways that Boeing could not have quantified in the uncertain years of the early 1920s.
The Kelly Airmail Act of 1925, which authorized the Post Office Department to contract with private carriers for airmail delivery,
opened the first major commercial aviation market in American history and positioned Boeing to make a decisive move toward vertical integration of the aviation supply chain. The Model 40A, designed specifically for airmail operations and introduced in 1927, incorporated a Pratt & Whitney Wasp air-cooled radio engine in place of the liquid-cooled engine used by competing designs, a substitution that reduced weight, improved reliability, and lowered maintenance costs on routes that could not support complex mechanical repairs in remote facilities. The Model 40A could carry 1,000 pounds of mail and 2 passengers in an enclosed forward cabin, and its per-mile operating economics were sufficiently favorable that Boeing's Airmail subsidiary rapidly expanded its route network across the western United States. William Boeing's entrepreneurial instincts led him in 1928 and early 1929 to assemble United Aircraft and Transport Corporation, a holding company that combined Boeing's airframe manufacturing operations, his Pacific Air Transport airline, Pratt & Whitney's engine business, Hamilton Standard Propeller, and several other aviation-related enterprises into a single corporate structure controlling virtually every element of the aviation supply chain.
The resulting entity attracted both commercial admiration and regulatory scrutiny. Congress, which had grown suspicious of concentrated industrial power across multiple sectors following the Great Crash of 1929, examined the structure through a series of investigations that culminated in the Airmail Act of 1934. The act prohibited companies that manufactured aircraft from also operating airlines that carried airmail under government contract, a provision that forced the dismantling of United Aircraft and Transport Corporation and separated the commercial airline operations, which would become United Airlines, from the manufacturing business. William Boeing, personally embittered by what he viewed as governmental overreach, sold all of his Boeing Aircraft Company shares and withdrew from the industry entirely, never returning to an operational role in the company that bore his name. He lived until 1956 and witnessed the company's transformation into one of the most powerful industrial enterprises in the world, but departed under conditions of institutional disruption that left a complicated personal legacy. The enforced restructuring, whatever its short-term disruption, ultimately produced a leaner Boeing Aircraft Company that could pursue military and commercial aircraft development without the regulatory complications that vertical integration into airline operations had created.
The mid-1930s brought Boeing a military design competition that would define the company's role in the approaching global conflict and establish its reputation for technical ambition on a scale that no previous program had approximated. The Army Air Corps issued a requirement in 1934 for a long-range coastal defense bomber capable of engaging naval threats at extended distances from American shores, and Boeing entered the contest with the Model 299, a 4-engine all-metal monoplane whose dimensions and specifications exceeded those of any competing entry from Douglas or Martin. The Model 299 first flew from Boeing Field on July 28, 1935, and a reporter from the Seattle Times, observing the aircraft's multiple defensive gun positions, described it as a flying fortress, a phrase Boeing trademarked and that would become one of the most recognized designations in the history of military aviation. The Army evaluation at Wright Field, Ohio, came to a premature end on October 30, 1935, when the Model 299 crashed on takeoff because a crew member had failed to disengage the elevator and rudder gust locks before commencing the takeoff roll, a human error unrelated to the aircraft's design, but one that nonetheless disqualified the Boeing entry from the immediate production contract, which was awarded to the smaller and less ambitious Douglas B-18 Bolo.
Boeing secured a developmental order for 13 YB-17 aircraft, and its engineering teams worked intensively through the late 1930s to refine successive variants as combat reports filtered back from the war already raging in Europe. Each major variant, the B, C, D, E, and F models, incorporated lessons from operational experience, adding armor protection, improving defensive armament, extending range, and reinforcing the airframe's structural integrity in ways that the original competition prototype had not anticipated. By the time the United States entered the war in December 1941, the B-17 had matured into a combat-proven platform whose design had been calibrated against the actual demands of sustained operations over defended territory, a refinement process that neither competing bomber had undergone at comparable depth. Boeing had bet the company's engineering capacity on a design that the Army had initially declined to purchase in production volume, and that commitment, which had nearly been extinguished in the Ohio crash of October 1935, ultimately proved one of the more consequential gambles in the history of American industrial competition. When the United States entered World War II following the attack on Pearl Harbor, Boeing's manufacturing operations were put on a war footing of unprecedented scale and speed. Plant 2, a large manufacturing facility adjacent to Boeing Field, south of Seattle, was given a wartime disguise that has no peacetime equivalent. The entire roof of the facility was covered with painted canvas, artificial turf, wooden structures, and plywood housing to create the appearance from altitude of a suburban residential neighborhood, protecting the factory against potential Japanese aerial attack in the anxious months of 1942. At the peak of B-17 production in 1944, Boeing and its production partners, Douglas Aircraft and Lockheed Vega, were completing and delivering 362 B-17 Flying Fortresses per month, a rate of output that required more than 40,000 workers in Boeing's Seattle area facilities alone, operating in multiple overlapping shifts that kept the production lines in near continuous motion. Women entered the Boeing workforce in substantial numbers during this period, performing work across nearly every production skill category: riveting, electrical wiring, precision assembly, inspection, that had previously been exclusively male, and eventually comprising approximately 40% of Boeing's wartime production labor force in Washington state. The B-17 Flying Fortress became the primary instrument of the 8th Air Force's strategic bombing campaign against German industrial and military infrastructure in the European theater, flying daylight precision bombing missions at altitudes between 20,000 and 30,000 feet in formations that could number several hundred aircraft on a single mission. By war's end, approximately 12,730 B-17s had been produced across the three-company consortium, an average production rate across the full war period of roughly one aircraft every 2.5 hours on a continuous basis, a figure whose logistics implications are as remarkable as the number itself. The aircraft's documented capacity to absorb severe battle damage and return crews to base earned it a reputation for structural resilience that was operationally verified rather than merely promotional. Cases of B-17s completing missions after losing significant portions of wing, tail, or fuselage structure became part of the type's operational record and contributed to crew confidence in a machine they were asked to fly into heavily defended airspace repeatedly. Boeing's ability to transition from a pre-war commercial manufacturer of modest production volumes to a mass production military organization in under 2 years, while simultaneously managing engineering refinements to the aircraft in response to combat experience, represented an organizational and industrial achievement whose difficulty is difficult to overstate from the vantage point of modern manufacturing practice. Even as the B-17 production system reached its operational peak, Boeing was developing a more ambitious aircraft that would determine the war's conclusion in the Pacific and permanently alter the strategic architecture of modern warfare. The B-29 requirement, issued by the Army Air Corps in 1940, called for a very long-range bomber capable of reaching targets in Japan from bases in China or the Mariana Islands, a mission profile that demanded range, altitude capability, and payload capacity far exceeding what any existing aircraft could provide. The B-29 Superfortress incorporated a pressurized crew compartment that allowed crews to operate at altitude in relative comfort, a computerized central fire control system that permitted a single gunner to operate multiple remote-controlled gun turrets, and a range capability that enabled missions of a duration and distance unprecedented in the history of military aviation up to that point. The program's total cost, according to various government records and historical analyses, exceeded that of the Manhattan Project in total appropriations, a comparison that some historians qualify on the grounds of differing accounting methods, but that reflects the extraordinary complexity and manufacturing challenges the B-29 presented.
Boeing's Wichita, Kansas facility bore a substantial share of the B-29 production burden, eventually completing more than 1,600 of the approximately 3,970 aircraft produced across the full manufacturing consortium, which also included facilities in Renton, Washington, and plants operated by Bell Aircraft and Martin. On August 6, 1945, the Enola Gay, a B-29 of the 509th Composite Group operating from North Field on Tinian Island, delivered the first atomic weapon used in combat against the city of Hiroshima, Japan. 3 days later, a second B-29 named Boxcar carried a second weapon to Nagasaki. The casualties from both attacks, including deaths attributed to radiation-related illness in subsequent months and years, are estimated by various historical sources at between 110,000 and 210,000, figures that remain subjects of ongoing scholarly discussion and that continue to inform international deliberations about nuclear weapons policy more than 8 decades later. The B-29 had made Boeing's manufacturing capability an instrument through which the United States chose to bring the most destructive conflict in human history to its close, a role that embedded Boeing's products permanently in the nation's reckoning with the use of military force.
The transition to peacetime confronted Boeing with the familiar challenge of maintaining an organization built around wartime production volumes in the absence of wartime demand, a structural problem that the aviation industry had confronted with largely dismal results after the previous World War. Boeing offered the Model 377 Stratocruiser to commercial airlines as a derivative of the C-97 military transport, itself derived from the B-29 airframe, providing a double-deck, pressurized long-range transport that Pan American World Airways and several other carriers purchased for their international routes. The Stratocruiser, which entered commercial service in 1949, offered appointments that reflected the pre-war understanding of air travel as an experience structured around comfort and relative exclusivity. A spiral staircase connected the main cabin to a lower-deck lounge and bar. Sleeping berths were available on overnight transatlantic crossings, and the passenger experience more closely resembled a first-class ocean liner compartment than any subsequent conception of commercial aviation would allow. However, the Stratocruiser's operating economics proved problematic. The aircraft was expensive to maintain, its reciprocating engines required intensive and skilled attention, and the market for long-distance travel at the fares necessary to recover operating costs was smaller than Boeing's projections had assumed. Military contracting remained Boeing's financial backbone through the late 1940s and into the 1950s, sustained by Cold War defense spending that was reshaping American industrial capacity in ways that would prove consequential for decades. Boeing's B-47 Stratojet, first flown in December 1947, established a swept-wing, multi-jet configuration that would define American bomber and aerial refueling tanker design for a generation. The B-52 Superfortress, first flown in April 1952 and entering service with the Strategic Air Command in 1955, became the foundational platform of American nuclear deterrence through the most dangerous decades of the Cold War confrontation with the Soviet Union. The B-52 was designed to deliver nuclear weapons to targets within the Soviet Union at altitudes and ranges that made interception extremely difficult, a mission whose credibility was central to American strategic posture through multiple presidential administrations and that defined the operational doctrine of the Strategic Air Command for 3 decades. What was not apparent in 1955 was that the B-52 would still be flying active combat missions and undergoing continuous capability upgrades into the 3rd decade of the 21st century, a service life that may ultimately exceed 100 years if current modernization programs proceed as planned, a longevity without precedent among major military aircraft types. The development of the Boeing 707 represented the company's most consequential strategic commitment since the B-17 program, a decision to invest the company's capital and engineering capacity in a commercial jet transport that had no guaranteed market and that required technology still being developed and refined in military applications. Boeing committed approximately $16 million of its own funds in 1952 to develop the Model 367-80, known internally as the Dash 80, a prototype jet transport intended to demonstrate both commercial passenger potential and military aerial refueling utility. The Air Force's decision to order the KC-135 Stratotanker in 1954 provided financial validation that helped offset the Dash 80 development costs, but the commercial variant, which required a wider fuselage than the military tanker version, had to stand on its own commercial merits. Pan American World Airways signed the launch customer agreement for the 707 in October 1955, committing to 20 aircraft in a transaction that obligated both parties to a technology not yet in revenue service and that linked Pan Am's competitive positioning to Boeing's delivery schedule.
The 707 entered commercial service with Pan American on October 26, 1958, on a transatlantic route between New York and Paris that reduced crossing time from more than 12 hours to approximately 7, a compression of travel time with implications not merely for individual convenience, but for the economics of transatlantic commerce and the accessibility of international travel to categories of travelers who had previously considered it impractical. The effect on commercial aviation economics was structural rather than incremental. Jet aircraft reduced per-seat operating costs substantially relative to piston engine transports, enabled higher load factors through more predictable scheduling, and opened route networks where propeller aircraft economics had been marginal at best. American Airlines moved rapidly to acquire the 707 and its Douglas DC-8 competitor, triggering an investment cycle that permanently altered the capital structure of the commercial aviation industry and created the passenger market ecosystem that would sustain aviation growth for the remainder of the century. By the time 707 production ended in 1991, Boeing had delivered 1,010 commercial 707s and military variants, a number that understates the aircraft's significance, since it was the platform that established the design vocabulary, manufacturing processes, and airline operator relationships that defined commercial aviation for the following 4 decades.
The Boeing 747 originated not in Boeing's engineering laboratories, but in a conversation, a question posed to Boeing sales leadership by Pan American World Airways President Juan Trippe, who asked in the mid-1960s whether it was possible to build a commercial transport more than twice the size of the 707 that could carry in excess of 400 passengers. Trippe's logic was rooted in the economics of democratization. If the per-seat cost of transatlantic jet travel could be reduced sufficiently, international air travel could become accessible to Americans of ordinary wages who had never imagined it within financial reach, creating a mass market for a product that had been structured exclusively for the affluent. Boeing President William Allen accepted the challenge at a meeting with Trippe in 1965, and Pan Am formally ordered 25 747s in April 1966 for approximately $525 million, a commitment of approximately $21 million per aircraft for a design that did not yet exist in engineered form, linking both companies' financial futures to the success of a program of extraordinary technical ambition.
The development program consumed Boeing's engineering talent at a rate and intensity that was, by accounts from participants documented in historical records, remarkable even by the standards of previous major programs. The design team worked under sustained pressure, whose demands were, by various accounts, reflected in documented stress-related health consequences among some of the engineers most intensively involved, though precise medical records on this point are not in the public domain, and the claim should be understood as historically reported rather than clinically verified. The Everett, Washington manufacturing facility, built specifically for 747 production, covering approximately 98 acres of enclosed floor space, is, by standard building volume measurements, the largest enclosed structure on Earth, a physical artifact of the program's scale that remains in active manufacturing use for 787 and 777 production. The 747-100 entered commercial service with Pan Am on January 21, 1970, on a New York to London route that marked a threshold in the history of commercial aviation, and the aircraft's twin-aisle wide-body configuration, capable of carrying between 366 and 524 passengers, depending on cabin arrangement, drove down per-seat costs sufficiently to allow fare reductions that made international travel accessible to millions of Americans who had never previously flown abroad. The last 747 was delivered to Atlas Air in January 2023, 57 years after the program's formal launch, one of the longest production runs in the history of commercial aircraft, and a measure of the durability of an engineering concept that had seemed, in 1966, audacious beyond reasonable expectation.
Boeing's relationship with Seattle and the Pacific Northwest extends far beyond the ordinary ties between a corporation and its home city, woven into the social and economic fabric of the region so completely that the two histories are, across multiple decades, effectively inseparable. At various points in the company's history, Boeing has employed a dominant share of the King County manufacturing workforce, and the patterns of residential development, school funding, transit infrastructure, and public investment across the Seattle metropolitan area bear the imprint of Boeing's hiring and layoff cycles in ways that remain visible in the built environment decades after the specific cycles that produced them. The most acute illustration of this structural dependency came in the years between 1969 and 1971, when the simultaneous collapse of the commercial aviation market, the cancellation of the American supersonic transport program on which Boeing had invested years of engineering effort, and a sharp contraction in defense spending combined to force Boeing to eliminate more than 60,000 positions in its Washington state workforce in approximately 2 years. The population of King County declined during this contraction, a demographic event unusual for a major American metropolitan area in the post-war period. And the billboard that appeared near Seattle-Tacoma International Airport reading, "Will the last person leaving Seattle please turn out the lights?" became an emblematic document of the period's economic distress, reproduced in subsequent decades as both historical artifact and cautionary reference point for regional economic planning discussions. Boeing's recovery through the 1970s and 1980s, driven by expanding 737 sales and a renewed defense and space market, restored employment to pre-crisis levels and stabilized the regional economy. But the episode had demonstrated with unmistakable clarity the systemic risk inherent in an economy so tightly coupled to a single large employer's production cycles. The company's 2001 decision to relocate its corporate headquarters from Seattle to Chicago, motivated partly by a desire to separate senior executive decision-making from any single manufacturing concentration, was received in the Pacific Northwest as a reorientation of institutional loyalty, even though the manufacturing facilities and the majority of the workforce remained in Washington state. The Everett complex, handling final assembly of the 787 Dreamliner and the 777X, remains one of the largest manufacturing employment sites in the state of Washington and continues to shape patterns of development, commuting, and public investment across Snohomish County in ways that persist regardless of where the corporation's leadership is physically located. The Boeing 737, which has become by a substantial margin the most widely produced commercial jet aircraft in history, had origins in the competitive pressures of the mid-1960s rather than in any particular engineering vision for a new transportation category. Boeing designed the 737 primarily as a response to the Douglas DC-9, which had entered service in 1965 and was capturing orders from airlines seeking smaller aircraft for thinner domestic routes that the larger 707 and 727 could not serve profitably. The 737-100 first flew on April 9, 1967, and entered commercial service with Lufthansa in February 1968. The German carrier's selection of an American aircraft over available European alternatives reflecting the 737's favorable operating economics rather than any particular patriotic preference. The aircraft's twin-engine configuration, compact fuselage, and short-field performance gave it operating economics well-suited to routes that larger jets could not serve profitably. And its modest first-generation sales performance understated the commercial momentum that successive variants would generate. The 737 Classic series, the 300, 400, and 500 variants introduced in the 1980s, replaced the original Pratt & Whitney JT8D engines with CFM56 high-bypass turbofans, substantially improving fuel efficiency and reducing the noise footprint to levels compatible with the increasingly stringent airport restrictions being imposed across major American and European markets. The 737 Next Generation series, launched in 1993 and entering service from 1997, offered further improvements in aerodynamics, range, and avionics integration, and the 737-800 variant in particular proved so commercially successful that it became for several years the best-selling commercial aircraft model in the world.
Airlines had built their operations, maintenance training, and crew qualification programs around the 737 platform to a degree that made switching to any alternative prohibitively expensive, a competitive moat that gave Boeing market stability, but that also created institutional incentives to extend the 737 platform's service life beyond what pure engineering logic might have recommended. By the early 2020s, total deliveries of all 737 variants exceeded 10,500 aircraft, a market penetration so deep that the 737 had become structurally embedded in the global aviation system in ways whose implications would become apparent when the type encountered regulatory crisis in 2019.
The merger between Boeing and McDonnell Douglas, completed in August 1997 for approximately $16.3 billion, was presented at the time as an industrial consolidation driven by rational competitive logic. Two of America's three surviving major aerospace manufacturers combining resources to compete more effectively against Airbus Industry, the European consortium that was steadily gaining market share in commercial aircraft. McDonnell Douglas had struggled through the late 1980s and early 1990s with financial difficulty, an aging product line, and defense revenues that had contracted sharply in the post-Cold War budget environment. Boeing, by contrast, was operating from commercial strength following the 737 Next Generation program's early success. What was less visible in the merger's immediate public presentation, and what has been more thoroughly examined in subsequent analysis, is the degree to which the transaction introduced into Boeing's senior leadership culture a management philosophy derived from McDonnell Douglas's sustained financial crisis experience, an environment in which cost reduction, shareholder return metrics, and production efficiency have been elevated above long-cycle investment in engineering capability. Several former McDonnell Douglas executives rose to positions of significant authority within the combined organization and implemented operational doctrines that a number of former Boeing engineers and aerospace analysts have characterized as systematically corrosive of the engineering-first institutional culture that had been Boeing's competitive foundation. The company's 2001 decision to relocate its corporate headquarters from Seattle to Chicago, physically separating senior executive leadership from the engineers and production workers who built the aircraft, has been cited by various analysts as both symptom and accelerant of this cultural shift, though the causal relationships are complex and the evidence on any specific link is often contested. What is objectively observable in Boeing's financial statements from the late 1990s through the 2010s is a trajectory of declining research and development investment in real terms, alongside increasing shareholder distributions through dividends and share repurchase programs, a capital allocation pattern that reflected broader trends in American corporate governance, but that had particular consequences for a company whose products required decade-long development timelines and whose safety architecture depended on sustained investment in accumulated engineering knowledge. The specific mechanisms by which institutional culture translates into product decisions and the precise degree to which the 1997 merger drove those mechanisms in Boeing's case remain subjects of ongoing analysis rather than settled historical conclusion. The Boeing 787 Dreamliner program, formally launched in April 2004, was structured around two genuine ambitions: the deployment of composite materials in an airframe at a scale never previously attempted in commercial aviation, and the distribution of development financial risk through a global supply chain architecture more extensively outsourced than any Boeing program had previously employed. The 787's airframe, constructed with approximately 50% carbon fiber reinforced polymer by weight, compared with the 12% composite content of the 767 it succeeded, delivered performance advantages that were real and measurable. The aircraft entered service approximately 20 to 25% more fuel efficient than comparable wide-body predecessors, with cabin altitude maintained at an equivalent of 6,000 feet rather than the 8,000-foot equivalent standard on earlier aircraft, and with cabin humidity levels measurably higher than aluminum airframes had previously permitted. These passenger environment improvements were supported by independent assessments and contributed to the 787's favorable reception among frequent long-haul travelers in its early years of commercial service. However, the supply chain architecture through which Boeing attempted to deliver the 787, delegating approximately 70% of design, engineering, fabrication, and testing to a global network of suppliers in Japan,
Italy, South Carolina, and other locations, with Boeing acting primarily as a systems integrator, produced consequences that the program's planning processes had not adequately anticipated. Fuselage sections arrived at the Everett Final Assembly Facility with structural deficiencies, missing fasteners, improperly installed shims, and documentation anomalies requiring extensive rework before the aircraft could advance through the assembly sequence. The first 787 was delivered to All Nippon Airways in September 2011, approximately 3.5 years behind the program's original schedule, and public estimates of the cumulative cost overrun, based on information Boeing has disclosed in financial filings and the analysis of independent aerospace economists, have placed the figure in the range of $11 billion above original projections, though Boeing has not provided a definitive consolidated program accounting. A lithium-ion battery fire problem that grounded the entire 787 fleet in January 2013, the first fleet-wide commercial grounding since the DC-10 in 1979, was resolved through a redesigned battery enclosure system approved by the FAA in April 2013. Quality anomalies in fuselage manufacturing resurfaced in 2020 and 2021, resulting in a delivery halt lasting more than a year, while Boeing conducted systematic inspections and rework of aircraft in inventory, a recurrence that reinforced concerns about whether the supply chain integration problems identified early in the program had been fully corrected.
The Boeing 737 MAX program was initiated not from engineering opportunity, but from competitive urgency, of an intensity that compressed decision-making timelines in a program whose safety implications demanded the opposite of compression. In December 2010, Airbus formally launched the A320neo family, a re-engined variant of its best-selling single-aisle aircraft, incorporating new-generation high-bypass turbofan engines, offering fuel efficiency improvements of approximately 15 to 20%, and the commercial response from airlines was rapid and substantial. American Airlines, which Boeing had historically considered a reliably captive 737 customer, announced in July 2011 that it was ordering 260 A320neo family aircraft without providing Boeing an opportunity to present a competing design, an event that produced significant urgency within Boeing's senior leadership. The decision to re-engine the 737 rather than develop a new aircraft, a clean sheet design would have required roughly a decade and development costs in the range of $20 billion or more, was driven by the calculation that the 737's type certificate, its airline operator relationships, and its deep global fleet penetration made the extension of the existing platform commercially preferable to the risks and timelines of an entirely new program.
The CFM LEAP 1B turbofan selected for the MAX was substantially larger in diameter than the engines on the 737 next generation, and the 737's historically low ground clearance required that the engines be repositioned forward and higher on the wing to maintain adequate clearance, a change that altered the aircraft's aerodynamic pitch behavior in certain flight conditions. Boeing's engineers developed the Maneuvering Characteristics Augmentation System, MCAS, a software function designed to automatically apply nose-down stabilizer trim when sensors indicated the aircraft's nose was pitched above a threshold angle, compensating for the pitch-up tendency introduced by the engine repositioning. The MCAS system was certified by the FAA under the Organization Designation Authorization Program, which delegated substantial portions of the safety review to Boeing's own designated engineering representatives, an arrangement standard in FAA practice for decades, but whose adequacy for a flight-critical system of MCAS's design and operational significance was subsequently questioned by the FAA's independent review panels, congressional investigators, and the Department of Transportation's Inspector General.
Documentation that emerged in later investigations indicated that some Boeing engineers had raised concerns about aspects of the MCAS design during the certification process. The degree to which those concerns were fully evaluated within Boeing's internal safety review procedures remained a subject of investigation as of the mid-2020s.
On October 29, 2018, Lion Air Flight 610, a Boeing 737 MAX 8, operated by the Indonesian carrier on a domestic service from Jakarta, entered an uncontrolled descent shortly after takeoff and struck the Java Sea at high speed approximately 13 minutes into the flight, killing all 189 people aboard.
The investigation conducted by Indonesian authorities, supported by flight data and cockpit voice recorder analysis, established that a malfunctioning angle of attack sensor had been providing erroneous data to the MCAS system, which repeatedly commanded the horizontal stabilizer to trim nose down against the flight crew's manual inputs. The crew, who had not been informed in their training materials of the MCAS system's existence, its operational logic, or specific procedures for its disabling, struggled to identify and counter a behavior outside their training curriculum. Documentation that emerged in subsequent investigations indicated that Boeing had, in its pilot training materials for the 737 MAX, omitted any mention of MCAS, a decision Boeing attributed to a determination that the system operated within the envelope of existing stabilizer trim procedures, a characterization disputed by the Indonesian investigators and subsequent congressional inquiry.
Less than 5 months later, on March 10, 2019, Ethiopian Airlines Flight 302, another 737 MAX 8, departing Addis Ababa International Airport on a scheduled service to Nairobi, crashed into farmland near the town of Ejere approximately 6 minutes after takeoff, killing all 157 people aboard, in circumstances that multiple investigating authorities determined were essentially identical in technical causation to the Lion Air accident, a faulty angle of attack sensor triggering MCAS commands that overpowered the flight crew's inputs, despite the crew's apparent attempt to follow the applicable emergency procedure. The two accidents killed 346 people in total. Aviation regulators across China, Europe, Canada, and most of the world grounded the 737 MAX fleet within days of the Ethiopian crash. The FAA, which had initially resisted the grounding while defending its certification process, issued its emergency order of prohibition on March 13, 2019, following White House pressure and international isolation of its position. Congressional investigators subsequently obtained internal Boeing communications produced during the aircraft's development period, including employee descriptions of the 737 MAX certification process in language that Boeing's own leadership publicly acknowledged was completely unacceptable, and those communications materially altered the public understanding of what had occurred inside the organization during the aircraft's development and certification.
The legal and regulatory aftermath of the 737 MAX accidents produced outcomes that were, by comparative historical standards, significant in the context of American aviation safety and corporate accountability, even as victims' families argued consistently that they fell far short of adequate consequence. The 737 MAX remained grounded globally for 20 months, from March 2019 until the FAA cleared the aircraft for return to service in November 2020, following Boeing's redesign of the MCAS system to require consistent readings from 2 angle of attack sensors before activation, a limitation of MCAS's authority over the stabilizer, and crew training supplements. Boeing's total financial exposure from the grounding, encompassing halted production costs, aircraft storage and preservation, supply chain compensation, and customer settlement payments, was estimated by financial analysts at more than $20 billion, a figure Boeing has not confirmed in a single consolidated disclosure. In January 2021, the Department of Justice announced a deferred prosecution agreement charging Boeing with 1 count of conspiracy to defraud the United States, specifically conspiring to deceive the FAA about the operational parameters and design characteristics of the MCAS system during the certification process.
Under the agreement, Boeing paid a total criminal monetary amount of approximately $2.5 billion, composed of a $243.6 million criminal monetary penalty, $1.77 billion in compensation to airline customers, and a $500 million fund for the families of the 346 crash victims, equivalent to approximately $1.45 million per death, a figure that victims' families and their legal representatives described as inadequate by the standards of civil wrongful death compensation and as grossly inadequate as a measure of criminal consequence. No individual Boeing employee faced criminal prosecution in connection with the deaths of 346 people, an outcome that the House of Representatives' final investigation report described as reflecting the limits of existing corporate criminal accountability frameworks as much as any specific evidentiary conclusion. The deferred prosecution agreement also required Boeing to implement a compliance and ethics program capable of preventing future regulatory fraud, a requirement whose subsequent enforcement would become the basis for additional criminal proceedings in 2024.
The 737 MAX returned to commercial service with the majority of its pre-grounding customers through 2021 and into 2022, though its reputational standing among the traveling public varied significantly by market and demographic segment, and some passengers explicitly sought itinerary alternatives to avoid flying the type.
On January 5, 2024, a door plug, a structural panel installed to cover an inactive emergency exit opening in the fuselage of a Boeing 737 MAX 9, separated from an Alaska Airlines aircraft at approximately 14,800 feet altitude, roughly 14 minutes after departure from Portland International Airport. The opening left in the fuselage was approximately 26 by 48 inches. The resulting decompression was experienced by passengers and crew as an explosive event. A child seated near the opening was partially displaced before being physically restrained, and the seat adjacent to the opening was by chance unoccupied at the time of the plug's departure. No fatalities resulted, though the National Transportation Safety Board's subsequent investigation characterized the outcome as contingent on circumstances, including the unoccupied adjacent seat, that could have produced fatalities had they differed by small margins. The NTSB found that 4 bolts required to secure the door plug in its installed position had not been installed at Boeing's Renton, Washington manufacturing facility, a deficiency that had not been detected by Boeing's quality inspection processes at the time of manufacture or during subsequent maintenance activities.
The FAA responded by temporarily capping 737 MAX production at existing rates, prohibiting expansion to higher output volumes, and conducting an intensive audit of Boeing's manufacturing quality systems that produced a formal notification of numerous alleged violations of federal aviation regulations. In July 2024, the Department of Justice determined that Boeing had breached its obligations under the January 2021 Deferred Prosecution Agreement by failing to design, implement, and enforce the required compliance and ethics program, removing the protection from prosecution the agreement had provided. Boeing agreed to plead guilty to the charge of conspiracy to defraud the United States and to pay an additional approximately $487 million in fines, a revised total that families of the 346 crash victims described as a fraction of what Boeing's conduct warranted, and to submit to 3 years of independent compliance monitoring, a supervision arrangement that imposed external oversight on the company's regulatory compliance processes for the first time in its history. In August 2024, Boeing's board of directors appointed Kelly Ortberg as president and chief executive officer, a selection that brought into the role an aerospace industry executive whose professional reputation was associated with manufacturing discipline and credible regulatory relationships rather than the financial engineering priorities that had shaped Boeing's leadership through much of the preceding decade. Ortberg had previously served as chief executive of Rockwell Collins, a major avionics and aerospace systems supplier, where he had overseen significant organizational change prior to Rockwell Collins's 2018 acquisition by United Technologies, an operating background that emphasized engineering rigor and supply chain management rather than investor relations. His appointment followed a period of leadership instability in which multiple executives had held the CEO role in rapid succession since the 737 MAX crisis emerged in 2019. And his selection was interpreted by aerospace analysts and labor union representatives as a signal that Boeing's board had concluded the company's most pressing institutional deficit was manufacturing credibility rather than financial strategy. In the months following his appointment, Ortberg implemented structural changes to Boeing's factory management. Production supervisors were explicitly authorized to halt assembly lines when quality standards were not met, a departure from the production rate incentive structure that former Boeing employees and union officials had identified as a contributing factor in the quality lapses of the preceding years. Ortberg acknowledged before a Senate Commerce Committee hearing in April 2025 that Boeing had made serious missteps and committed to sweeping changes in organizational structure, safety culture, and regulatory relationships. By early 2026, the 787 Dreamliner production line, which had been suspended for much of 2021 and 2022 following the discovery of fuselage manufacturing defects, had been restored to a delivery rate of approximately 8 aircraft per month, with stated targets of reaching 10 per month later in the year. The reacquisition of Spirit Aerosystems, the fuselage supplier Boeing had spun off in 2005, and that had subsequently been identified as a significant source of quality problems in both the MAX and Dreamliner programs, was completed in mid-2025, reintegrating manufacturing operations that Boeing's earlier cost reduction strategies had determined were better handled by an independent supplier.
The path to restoring both production rates and regulatory confidence remained, in the assessment of independent aviation analysts and the FAA's own public statements, substantially incomplete as of mid-2026, with no clear end date attached to the enhanced FAA oversight established following the Alaska Airlines incident. Boeing's defense and space portfolio, which receives substantially less public attention than the commercial aircraft controversies of recent years, constitutes a dimension of the company's operations whose strategic and financial significance is not subordinate to its commercial identity, and whose history encompasses contributions of a scope that few American industrial enterprises can claim. The B-29 Superfortress, whose design first flew in April 1952 and whose operational service with the Strategic Air Command began in 1955, has remained continuously active in the U.S. Air Force's inventory into the third decade of the 21st century, a service life that, with the Air Force's current B-52J re-engine program, incorporating Rolls-Royce F-130 turbofans, planned for completion in the 2030s, may extend the aircraft's active duty past 2050, giving a single military design a century-long operational span without precedent in aviation history. Boeing has supplied multiple generations of presidential transport aircraft, with the current VC-25A, a modified 747-200 that entered service in 1990, serving as one of the most recognized aircraft in the world as a tangible symbol of American executive authority. Its successor, the VC-25B, based on the 747-8 airframe, remained in development as of mid-2026 under a program that had experienced significant schedule delays and cost adjustments from its original delivery projections. In the space domain, Boeing built the first stage of the Saturn V launch vehicle, the rocket that carried all 6 successful Apollo lunar landing missions between 1969 and 1972, a contribution that, whatever Boeing's subsequent institutional trajectory, represents a permanent and documented place in the history of human exploration. Boeing's more recent space contributions have been more contested. The Space Launch System's core stage, under Boeing's prime contract, has accumulated cost overruns and schedule delays that NASA's Inspector General has documented in a series of public reports. And the CST-100 Starliner crewed spacecraft experienced a mission in 2024 in which 2 NASA astronauts were transported to the International Space Station, but the spacecraft was assessed as insufficiently reliable to carry them home, resulting in their extended stay and eventual return aboard a SpaceX Dragon capsule, an outcome that substantially damaged the Starliner program's commercial and operational prospects and added a space domain chapter to the quality narrative that had been building in Boeing's commercial aircraft context through the preceding decade.
Boeing's history across more than a century does not resolve cleanly into the standard narrative of American industrial triumph, and any honest accounting of what the company has been and what it represents must hold simultaneously the genuinely extraordinary achievements and the deeply consequential failures that together constitute its full record. The 707 and the 747 did not merely provide transportation, they reorganized the economics of global commerce, reshaped the geography of tourism and human connection, and made possible forms of international exchange whose full consequences are still being worked through in the political and cultural life of the 21st century. The B-17, the B-29, the B-52, and the KC-135 are woven into the operational history of American military power at decisive junctures in the defense of democratic institutions and the management of strategic competition. Contributions that are not abstract, but measurable in the outcomes of conflicts and deterrence relationships that shaped the world as it now exists.
The hundreds of thousands of skilled manufacturing jobs Boeing created and sustained in Seattle, Wichita, and across multiple states provided economic foundations for working-class communities that comparable manufacturing employment has been progressively less available to supply as the American industrial landscape has contracted over the past 4 decades.
These achievements are not qualified by what followed them. They are documented facts of the company's contribution to American industrial capability and national power. What is also documented, and what cannot be rendered invisible by the weight of prior achievement, is that Boeing brought the 737 MAX to certification and commercial service while concealing from the FAA material information about a flight-critical system's design and operational characteristics, and that this concealment, whatever its precise legal classification, contributed to the deaths of 346 people on 2 continents. The question of how an institution that once defined the standard for American engineering excellence arrived at that outcome, through what sequence of decisions, institutional pressures, and cultural erosions, the company that built the B-17 and the 747 became the company that certified the MAX, remains open in ways that neither Ortberg's reform program nor the Justice Department's settlements have yet conclusively resolved.
Boeing remains, by any analysis of its strategic position, an enterprise whose continued viability is of sufficient national consequence in commercial aviation market function, in defense manufacturing, in the stability of thousands of supplier relationships across multiple states, that the federal government cannot credibly allow its failure. And that structural reality, which Boeing's leadership has at times appeared to treat as a guarantee of tolerance for substandard performance, rather than as a responsibility demanding heightened standards, is itself one of the deepest unresolved tensions in the company's present and in its uncertain future.